Welcome back, students. Welcome to the course Natural Language Processing. My name is Priyanka Gupta. I am working as Assistant Professor in Department of Computer Science and Engineering in Data Science Department at Institute of Aeronautical Engineering, Hyderabad. Today I am going to discuss about information extraction. In that, we have seen in the last class that how to extract different tokens, different information from the paragraph and sentences. Today I will show you how that will be represented in the form of trees and how to do the word embeddings. So these are today's topic. So what is tree actually? A tree is a set of connected labels, that labeled nodes that is going to reach by the unique path from the root node. So each reachable node will be by a unique path from a distinguished root node. So from there the tree is going to be start. That particular node will be called as a root node. So let's take an example of a tree. Here they that in this tree actually they are strandly drawn by upside down. So upside and down. So here let's see here that here S is there. Their child nodes are NP and VP. Right. Again VP node child is V and NP, and again the NP child is DET and N. So what is actually N? N is the noun. VP is the verb. Here also verb, noun. That is delimiter. That is noun again. So now that will be when it will be written as a NP. So that will be just categorized as a singular noun, right? Singular noun or a plural noun. So like that. If P is there, plural noun. So likewise this tree is there. So one sentence is there. Alice chased the rabbit. So for that how the information has been extracted and that has been made as a particular word, as a token, and the token is also how it has been classified according to the grammar. So what grammar structure will be there, and that we are going to represent in the form of tree-like structure. That also what are the different tokens are there in the form of POS tagging, part of speech tagging, that will be just considered in this tree. So here we have seen S is there, NP is there. So Alice is nothing but that is noun but plural noun. Again the one other node has been just classified as a verb. So verb again it will be classified as a verb and noun. So verb is it has been used as a chase. Chase is again a verb. So verb, and again delimiter is the, and again noun is rabbit. So like that the tree structure is there for that particular word, that is Alice chased the rabbit. So likewise that we are going to just represent the different part of speech tagging of the sentence, a word, a paragraph also. So we use a family metaphor whenever we are talking about the relationship between the nodes in any type of tree. So this tree is going to be represent some relationship between the two words, between the two tokens. So we are going to discuss about that. That is actually making a family itself, because it is going to be just represented in the form of tree, and tree is going to be just show us the right node, left node, and that is also that will be called as a child node. So these are all making some relationship between them. So for example, here we have seen S was there. So S was the parent of VP. S was the parent of VP, and conversely VP is the child of S. So likewise that some relationship they two nodes are making with each other, and if it is child node, that some other node is going to be parent of that. So likewise some relationship it is there in this tree. Also when we will see NP, so NP and VP are both the children of S. So when it has been started from S as a root node, so two left and right node were there as a child. So that were the children of S, and they are also siblings. And whenever we'll talk about NP and VP, so they are making some relationship between them. They are sibling to each other, right? If S is parent, so they will be sibling to each other. So for example, for convenience, there is also a text format for specifying this type of tree. So how to represent this tree in the form of text format? So let's see here. So here the bracket, small bracket will be just open. We will write capital S, then we will again start a small bracket again, and we will write NP, and then we will write that what the NP is just belonging to. So that is belonging to LIs. So we will write LIs and brackets close, this bracket close. Again one bracket will be open for VP, that is going to make a left child. So then we will write VP, and in VP that is going to make verb. So in again one small bracket will be open, and V will be considered as verb. V is going to be belong to chased. Chased will be written here and bracket close. Again one bracket will be open, NP will be considered, and again one bracket will be open, determinator and THE and bracket close. Again one bracket will be open, and then N and rabbit, and all bracket will be closed here itself. Why? Because the tree is going to be closed here whenever it is making some relationship, right? So when it is having some relationship, the bracket will close, but it will not, bracket will open, but it is not going to be closed. It is going to be closed whenever the whole relationship will be completed. So likewise that we can write the text format for this particular tree. So although we will focus on the syntactic trees. So we are going to be just work on the whatever tree is having the syntax, and tree can be used for encoding any homogeneous hierarchical structure. So any one type of structure, any one type of hierarchical representation will be there, relation will be there. Then we are going to just use this type of representation in the form of tree, that is actually going to spawn, that is going to make a sequence of linguistic forms. So linguistic form is going to give us the grammatical structure out of that particular tree, right, in the form of relationship. So for example, we can conclude this with a morphological structure. We can also conclude the discourse structure. Likewise, this, some structures we can conclude. So these type of structures we have to follow in this linguistic form. So in the general case, if I'll discuss, so leaves and nodes also don't have the have to be siblings. So leaf and node values don't have to be strings. So they don't have to be string whenever it is starting in any general case. If I talk about the NLTK library, so in NLTK library we have to create a tree by giving a node level and a list of children. So we need to specify those in the definition. So how to represent those in the NLTK library in Python programming language? Let's see. So first of all, I am going to make a variable that is called as a tree1, right? Just to save the variables, other variables and functions in that. So tree1 is equal to nltk.tree. So again, .tree is a function that is a module in NLTK library that is going to be used for to represent the tree like structure. So directly I can call that. So nltk.capital T and REE tree, and in bracket in the function I will write in the single quotes NP comma, and in square bracket and single quotes LIs. So what relationship, what we are going to represent with this particular noun plural. So we are going to, we need to write that. We need to give definition, then only it is going to just understand that. In the next line, if I'll just going to print that tree, so that is going to write as a print in a small bracket, we need to write tree1. So that variable we have declared here. So this function is going to be just call here, and that is going to give us in a small bracket NP space LIs. So that first root node will be there for this tree. So only one node is there, so it is going to represent same as it is. In the next, if I'll talk about some other representation, so I will take a tree2 variable. So tree2 is equal to nltk.tree, and then in the small bracket I'm going to write the next node, that is in the small brackets. So I will write in the small bracket open, and that in the single quotes NP. noun plural, and comma. In the square bracket again I need to write two of the nodes. So first I will write in the small single quotes the delimiter, comma, rabbit. That is again in the single quotes. Rabbit in the single quotes, and square bracket close, and that small bracket also will be closed. Then if I will write, I will call the print tree2, then it is going to give the NP, the rabbit, right? So like this we need to represent each and every node, and we can say tokens while by writing to representing in the form of PS tagging. Let's see other examples. So we can also incorporate these into successfully larger trees. So how to represent those in the larger trees? So let's see, let's take another variable tree3. Tree3 is equal to nltk.tree, and in the small bracket I'm going to write in the single quotes VP, comma, in the square brackets in the single quotes chased, comma, tree2. So here I'm going to just call that tree2 what I have declared in the earlier slide directly, and square bracket close and single bracket also close. And for the tree4, if I'll write again, I will call tree1 and tree3 here directly. So I can write tree4 is equal to nltk.tree, and in the single quote I am going to write in the single quotes S, capital S, comma, in the square bracket tree1, comma, tree3. Square bracket close, single bracket close. Then if I print the tree4, so what it is going to give? The whole structure of this all trees, what variables we have declared in the form of tree. Then it is going to give when I will print tree4, that is going to give this as NP alias VP chase NP the rabbit. This is the whole structure of this particular tree what we have declared here, right? So likewise that in the smaller structure we need to give the all trees like that. So here are some of the methods available for the tree object. Let's see those. So here we can also use the indexes to represent the suppose if I need to write print, and if I need to call tree4 and in the square bracket 1, that is going to give the VP chased NP the rabbit. So whatever will be there in the first layer of this particular tree, that is going to give us. Again, if I'll write tree4 and in square bracket 1 dot label. So what is the label? What is the label in this particular layer of the first layer of this tree? So that is going to give VP. That is VP. If I will write tree4 dot leaves, it is going to represent the function with the function tree leaves function, that is going to give the alias chased the rabbit. These four are the leaves for this particular tree. Let's see if I will write tree4 in the square bracket 1 is in the square bracket 1, again in the square bracket 1. What it will just understand, it is going to just understand the different layers. So rabbit is present in the last layer. So first layer, second layer and third layer. So we need to write like this: first layer, second layer, third layer. Then we can just call the rabbit here, the rabbit node. So likewise that these are the different other methods are there to just understand what other nodes are there, or what other we can say child nodes or other things are there in this particular tree or any other type of tree. We also need to discuss the bracketed representation for complex trees can be difficult to read sometimes. So in these cases, whenever this longer trees will be followed to just start to write with the text format, so we need to just call the draw method. That can be very, very useful. So in that actually it opens a new window that is containing a graphical representation of the tree. So whenever we need to write, we need to just call the larger amount of large trees. So whenever we will write in the text format, that will be difficult to understand that. Then we need to just call the drawing method of that. So we need to just plot those type of trees directly, and we can understand all the nodes and all the part of taggings, whatever has been used in the form of tokens. So what we will do, we will call the draw function. So the tree display is going to be allow us to zoom in and zoom out, to collage and expand the subtrees also. So that is the use of this particular draw method, and that is also going to print the graphical representation of a PostScript file that is going to be for inclusion in a document. So if I will write in the to represent this whatever tree we have tree format we have written in the earlier slides, if I'll call tree3 dot draw function, draw and function, so it is going to just draw the whatever nodes will be there in the tree3 variable, t3 variable. So let's see, that is going to give us the NLTK with the NLTK library. Let's see here. So that is going to give the VP as a root node. Then two left and right child will be there. The left child will be the saw, and the right child will be the NP. So NP is the token. It is going to be again take the other we can say part of that sentence. So that is going to be represented by, in the left and right child, the N-man. So this is a we can say draw method of the to represent the different type of trees at the in the NLTK library. So in this represented, by using this type of represented, we are going to understand more. Any end user is going to be understand more about the different tokens and different larger trees, and what are the other nodes are there, what are the relationships are there, what are the verbs are there, what adverbs are there. So for that they are going to understand more in the linguistic manner. They are going to understand the linguistic science behind the different sentences also. So that is a need of to draw the tree here. So let's see what is actually word embedding. So since we know almost all the machine learning algorithm work on the mathematical equation, right? So we need to call the different algorithm rhythms in the form of mathematical manner. We need to write the different formulas, we need to write the different functions, as well as we need to write the variable for them to declare, to just call those functions with the help of variable. So that is going to be contained variable, and that is going to need information represented as a number. So whenever the words of, we can say, sentences is going to be just applied with the machine learning algorithm, that particular word or sentence is going to be just changed in the form of numerical aspects. That is going to be changed in the numerical number. So that is going to make some embeddings, right? So by that representation, before we are applying any kind of machine learning algorithm, we need the information extraction. So whatever sentences or words will be used, that is going to represent in the machine learning form with the some numbers. So that words need to be converted to a numerical representation after applying the machine learning algorithm, and that is going to make a array-like structure, a array of numbers in the form of some we can say vector like structure. So this array of numbers is called as embedding. We can also call these numbers array of numbers as a vector representation of a word. So for each word, for each piece of word and tokens, the machine learning algorithm is going to be just change these all words in the form of different array of numbers, and that is going to make a number of we can say embeddings of vectors in for the different sentences, different words in a sentence. So that is a use of word embedding. And if I will talk about how it is going to be mapped, how it is going to make a we can say a structure. So let's see, each word is mapped to a vector, something like if I will write if I will just write a sentence, Barack Obama was the president. So that is a one sentence. If I will write Barack Obama was the precedent. So how the machine learning algorithm is going to just represent these different words, these different 5 words are there, right? And that is going to be just converted in the form of different numerical forms, numerical numbers. And that also it is going to make a vector of arrays, right? So let's see, if I will consider the Barak. So Barak is going to make one embedding, one vector like 1 0 0 0 0. All commas will be there. Like that, likewise that the Obama is going to make one array like structure that is 0 1 0 0 0. Was is going to make 0 0 1 0 0. The is going to make 0 0 0 1 0. And again the precedent is going to just make a vector like a structure that is 0 0 0 0 and at last 1. So these are each word vectors are there. Vectors are there that is going to be just called as in the form of embedding a vector representation. So whenever we will apply the machine learning algorithm, that is going to understand each word in the sentence, we can say a number of sentences in a paragraph in the form of numbers, and that will be easy to just work on that whenever we are doing the text processing, whenever we are doing the text we can say normalization, that these are the we can say methods and task is going to be just used to just make simplify the other task to each other, whenever it is going to be just normalize the things in the form of numbers, in the form of some tree like structure, in the form of some embeddings. So these two things I have talked today. That is, first is tree, how it is going to be just applied on the different sentences and paragraph. We can say document, that is going to make simplify that particular document, and that is going to give us the tree like structure for each sentence. And with the help of that part of speech tagging, that is going to make separated as a node for each of the word with the help of part of speech tags. So then with the linguistic sign, that is going to make some different we can say nodes, that if it is suppose verb, so that is going to make another node for that. So likewise that we have seen it is going to be just formed in the tree like structure, and whenever we need to write in the form of text, we need to write more syntax for that. Syntax, it is going to represent the syntactical structure, and if I need to just represent those in the analytical library, I will use the draw function to just represent in the form of tree like structure. That actually is going to be make it easy to understand to the end users, also for the applications. So for the larger and complicated application, where we can just need to just draw that particular we can say document in the form of tree, and we can understand more about that linguistic science and different grammatical structure more. And whenever we need to just apply the machine learning algorithm for these words also, we need to just apply the word embeddings, that is going to just make those each of the words from the sentences as a particular one vector. We can say that is a we can say a form of array of numbers will be represented to form one word, and that is going to make simplify, that is going to make normalize our work whenever we are going to just do apply the different natural language processing techniques on that, and we can make we can do the text pre-processing easily by applying these embeddings and vectors and these tree like structures, and that is going to make it in the form of we can say simplified manner, simplified tokens it is going to make, and that is going to give the simpler to simpler representation, and the end users and the we can say the researchers, they can understand more about the each of the words and linguistic sign behind that. Whenever we need to just applying the different we can say text document for the purpose, and whenever we need to just extract the useful information, we need to just extract the different information from that, different keys from that, so we need to apply this word embeddings at there. So that was all about today's topic. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.